Welcome to another episode of The Rocks of Utah. I've been wanting to film a new video for a very long time. I've been planning on visiting some of the more iconic geological formations in Utah, but this particular geological layer is so famous and well known that I've been a little nervous to make a new video on it. So today I'm just visiting a few of the many places across southern Utah where this rock layer is exposed. This is the story of the Jurassic Navajo Sandstone. So I'm up at the lookout point above the canyons, and it's just actually really kind of cool to come up here because you can see, a huge extent of the Navajo Sandstone from this vantage point. So you can see the lower contact down here, and then these big dramatic cliffs are the Navajo Sandstone, and you can really get a sense of their scale of how thick they are in this part of Utah. Now, the Jurassic Navajo Sandstone forms the upper part of the Glen Canyon group, with the redder colored Kayenta, Springdale Sandstone, and Monavi formations that are below. Now, what makes the Navajo Sandstone so, I think, iconic is that it's formed by layers of ancient Aeolian sands, kind of representing fossilized sand dunes. So these rocks are lithified remains of a vast wind-blown sand that have been fossilized or lithified into these beautiful patterns of long wavy cross-bedding and banded colors of red, white, and tan. So here you can see right there how the beds down here are kind of in this orientation here. Boop, 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 boop. And then these that are above are cutting down an orientation kind of like that. And there's a contact there. So these are being deposited on the lee side of the sand dune. And then the wind is eroding off this here. And then the next storm comes in and deposits on top of that. Now, one of the best places to see the Navajo Sandstone is in the southwestern region of the state, where the Navajo Sandstone thickens upwards to 1,000 meters thick, or nearly a kilometer. So from outer space, this region of Utah looks like a fractured landscape of north-south directed, narrow and straight crevasses that are carved deep into the topographic edge of the Great Basin that's off to our west. Now, the fractured structure of these numerous slot canyons is the result of an uplift, the folding of an uplift that's called the Kaibab upwarp that extends into northern Arizona, and a series of faults that run north-south along the axis of the Wasatch Range to the north, such as the Hurricane and Severe faults that run through this area. So as the brittle and thick sandstone layers then folded over with this uplift, the outer surface of the sandstone expanded east-west in that direction, and that resulted in these thin, narrow vertical faults running the length of the folded upwarp, kind of like the cracks that are in the knuckles of my fist following the axis of the joint. Now, recent geochemical studies of the colors exposed in the Navajo Sandstone have shown that the basic reddish, kind of pinkish color of the sandstone is due to just a small fraction of iron oxides present in the sandstone. And that gives the canyons that beautiful kind of rust kind of pinkish coral kind of look to them. The more white and bleached bands are a result of the presence of aluminum oxide minerals and clay minerals like kaolinite. And both of those are kind of whiter in color, and that kind of bleaches out some of the sandstones in particular areas. Now, the darker sort of black color are a result of iron oxide minerals like hematite, and they can actually form these concretions in the sandstone, these kind of black concretions in the sandstone. Though oxidation of manganese likely also makes the weathered black stripes or lines following the paths of oxygen-rich ground and surface waters that are dripping from springs high up in the canyon walls, and that stains it that elegant black color. Now, the sandstones of the Navajo Sandstone are highly porous, and they allow the flow of groundwater between the grains of sand. So this flow of water and minerals really alters the banding and color of the rock. So the top layers of the Navajo Sandstone are bleached a light white color, which you can actually see from outer space. And those layers have been exposed to more weathering, while the lower layers tend to be more reddish brown in color. And these colors and bands can be seen throughout Zion National Park, especially if you are hiking up Angel Landing in that area. So these massive sandstones represent a vast and very ancient sand dune desert that covered much of the American West around 200 million years ago. You want to listen in on a geology lecture? Yeah. You ready? I'm telling everybody about the sandstone here. The Navajo Sandstone. What do you think? Oh, I got a little bored there, I guess. These sedimentary structures preserve the low cross-bedding patterns in the rock as the wind-blown sand moves upward to the top of the dune crest and fall into the backslip face, or the lee side of the sand dune. These grains fall into the basin, sheltered from the wind, forming a tilted bedding plane. Now, the straw side, or that's the wind-facing side of the sand dune, is eroded from the blowing wind, forming a wind erosional zone that cuts across the beds of sand. Another real good characteristic of the Navajo Sandstone is that it's very well sorted. Excellent sorting. So all the sand grains that form this rock are equal size, and they're very well rounded. It almost feels like a nice smooth kind of sandpaper. Winds blowing through the canyon as I film this. Can hear it. So here's a big huge slab of the Navajo Sandstone, and you can kind of orient it how it was deposited. So this surface here, these are the surface of the lee side of the sand dune. So these are good places to look for like little tracks of traceways of animals that were scurrying on the dune, and it was being deposited. So these down here, or in the foreground here, are the oldest, and then each layer is younger and younger going this way. But then if you come over here and you look on it stacked up, you can see how little of that sediment was being deposited. It's really fine little beds. Now we're looking on the surface of those beds as they were being laid down in the sand dune. Now, these patterns that we see in the Navajo Sandstone are the classic deposition of Barchan dunes that form these long cross bedding at an angle of repose between about 13 to 45 degrees. Now, massive transitional dunes can form that are actually perpendicular to the direction of the wind, so we can kind of understand a little bit the prevailing wind direction in Utah 200 million years ago when these sand dunes were being deposited. Now, I've read kind of a lot of studies that try to estimate how the geographic extent of this ancient sand dune desert, or what we call an erg, from the Arabic word for a sand sea desert. And many cite that it was one of the largest in the world, but kind of just doing some comparisons of some of our modern sand sea deserts that we have, like the Ruba Kali Desert in Saudi Arabia. Those are likely, a bit larger than the ancient desert that was here in North America. So while really massive in size, this ancient sand sea was not out of the ordinary to modern sand seas like in North Africa, Arabia, but much larger than any of the North American sand seas that we have today. So today I'm heading down a trail in the Kolob Canyon area of Zion National Park because I'm fascinated by what caused this great sand sea to form. So one of the reasons that I picked this area to come up and film a video about the Navajo Sandstone was that this area was visited by the famous landscape artist Thomas Moran in 1873. And he came up here with a friend. He's more famous, I think, for his paintings up in Yellowstone and the Grand Canyon. With some of the geological surveys, but he actually came up here on his own with a friend and did some of the early paintings of this area, landscape paintings and sketches that he drew and showcased back east. This valley here is the area where he had painted with these big, huge buttes of Navajo sandstone behind me. So it's a very picturesque area, kind of famous. A little more secluded than the main part of Zion National Park. So early geologists have argued that these sand dunes were basically impeded somehow by an uplift during the early Jurassic period, likely due to the accretion of exotic terrain from the west smacking into North America, the North American continent, causing an uplift. But geologists sort of started to kind of refute this because they haven't been able to find much evidence for a major uplift of a tectonic event to cause this. In fact, the sedimentary layers actually below the Navajo Sandstone indicate a wet, moist environment with rivers, ponds, and lakes, for example. The lower Monavi contains fossilized freshwater fish and some sharks, in fact. There also was probably a place that was popular with dinosaurs because there's tons of dinosaur tracks that are found in that formation. So the newer model is this idea that what caused the sand sea to develop was that Earth's climate seems to have undergone a rapid change from the cooler, wetter environment composing the bedded shales and mudstones to the hot desert sand dunes that are above in the Navajo Sandstone. So the change in lithological characteristics seems to be tied to a rapid global warming event, one that would change the landscape of this region into a very hot, dry desert for millions of years. So here we are kind of at the base, and you can see these surfaces that are often interpreted as being wadis in the wetter part of the lower part of the formation. This is probably Kayenta, but as you get up a little bit higher into those Aeolian sands, you get into the Navajo. But you can see that this is definitely, get these little white bands, these little wetter pond sort of deposits that are in here. But as you turn around and look up in these big, huge sands, those are all Aeolian up there. So you're definitely getting this sequence of drying out. So here's the Monavi, Kayenta. I think this is the little sandstone in the Kayenta, that's the bottom, and then you get into the Navajo up there. Now, dating these rock layers has proven to be really a major challenge to geologists. The age of zircon crystals from the formation indicate that the Navajo sandstone was deposited about 200 million years ago, where the youngest detrital zircon crystals are found up to that's the youngest date that they find those crystals at. Now, these zircons likely arose from ash layers that came in from volcanic fields far to the east. And something major was happening back east that was, during this period of time, that was really having some ramifications here in Utah and starting to change the climate. Now, geologists call this event that happens 200 million years ago CAMP, or C-A-M-P, and that's the acronym that geologists use to describe this major global warming event that occurred 200 million years ago that really had a major, profound effect on the global climate, not only here in Utah, but elsewhere around the world. This is the Central Atlantic Magmatic Providence, which produced this massive volcanic eruptions and volcanoes that were beginning the process of opening the Atlantic Ocean for the first time. Now, large basalts or lava flows have been dated to this event in western North Africa, over there in Morocco, western part of the United States, up into the region of New York City, in that area, in Brazil, in South America. And these major volcanic eruptions broke through the massive mountain of the Appalachians as it began to fall away, and we start to form the supercontinent, or start to break apart the supercontinent of Pangaea for the first time. So this occurred right at 200 million years ago, right at the boundary between the Triassic below and the Jurassic above in the Mesozoic era. Now, this event had a profound effect on the types of life on the planet. For over 50 million years, the Triassic period was a period of climate extremes. But by the end of the Triassic period, the planet was returning to a period of normality. But then it was plunged again into a new hot and dry climate that would change everything. I think people have been kind of conditioned into this idea that the Jurassic period, the age of dinosaurs, was wet and tropical. But actually at the beginning of the golden age of dinosaurs, it was not wet, it was not humid, it was actually bone dry here in Utah. This vast desert was the home to roving bands of dinosaurs, adapted to this harsh, dry, ancient desert. Now, dinosaurs are best adapted to deserts because they have the element of speed. They can race from place to place to find food and water in this desert, leaving the bizarre animals of the Triassic period, like the water-loving crocodile-like phytosaurs, behind. In fact, the phytosaurs basically go extinct near this boundary. Now, recent studies have begun to pinpoint the Triassic-Jurassic boundary in these sets of rock layers, placing it somewhere in the Monavi Formation, in the Dinosaur Canyon member, or the Whitmore Point member, but also possibly near the Springdale Sandstone or Kayenta Formation, or possibly a little higher near the base of the Navajo Sandstone, indicating that these thick and beautiful sandstones are the gradual repercussions of this major global warming event. Now, because of the difficulty in knowing the precise timing of the Triassic-Jurassic boundary in these rocks, we don't know exactly where this change occurred, and there are indications that the major volcanic eruptions span several thousands of years. So the theory goes that the massive volcanic eruptions spewed carbon dioxide and other gases into the atmosphere, warming the planet significantly. The ponds, lakes, and rivers dried up, leaving the landscape devoid of plants and vegetation that were holding down the sand and dirt. So they began to erode with the wind as things dried up. Now, these sand particles raced across the landscape, piling up sand dunes for the first time, and the desert began to expand from the dry interior. And in fact, these large sets of sand dunes likely formed fairly quickly, and basically are sets of decadal sort of cycles of sand dunes that represent maybe just only a few thousand years or so of deposition, since there's a lot of sand that can accumulate very shortly because of wind. Now, one of the challenges to kind of prove that this theory, this idea that climate change was responsible for the sand sea, is that it's very difficult to collect the isotopes of carbon and oxygen from these rock layers. These wind-blown sands lack much of the organic carbon and carbonate that is typically found in, say, limestone or coal-bearing rocks, making measurements of carbon and oxygen isotopes nearly impossible in these barren sandstones of the Navajo Sandstone. So it's really hard to actually correlate between regions, and this requires using magnetic stratigraphy, radioactive isotopes, dating of zircon crystals that have been done, and other scientific methods that are in development to basically try to correlate where the Triassic-Jurassic boundary is and this just enormous thick layers of rock. And I think all geologists actually agree that the Navajo Sandstone is early Jurassic in age, forming a vast sand dune desert around 200 million years ago. But its existence also kind of at warning that vast changes on our planet can occur very quickly and cause really major changes to a landscape going from wet, sort of tropical, moist lakes and rivers to a bone-dry desert of a sand sea that looks like something like from North Africa or Arabia today. So I think a more in-depth study of this iconic sandstone will hopefully unlock some of these mysteries yet to be solved, such as did a global climatic event create this unique and beloved landscape of Utah?